Okay, good morning everyone. So thank you for subscribing to my video. Thank you. If you're not subscribed, please subscribe. Okay, thank you for liking my videos previously. So today we're going to talk about function. Okay, so how does function work and how do we interpret function? We'll actually have a look at that today. Okay, first, inside function here, we know we have three subsections, which is the main function itself, composite function and inverse function. So I divided my video into three parts. So today we'll be discussing about functions, and this here is the summary. You can actually have a look at it and how does the function work. Okay, let's go. So the main components I'm going to discuss here today is, firstly, is how does the relation and the function works. Okay, first of all, for part A here. Okay, so how does this function look like? Look, okay, if you can see, we look at x and y. First, x is your object, okay, and this is y is your image. Okay, so how many objects are pointed towards the image? If you see 4 is pointing to 1, 8 is pointing to 1, which is logically speaking is many to 1. Then if you notice 5 is pointing to 2. So actually if you actually take note here, there is a many to 1 and 1 to 1 direction here. So we usually take the odd situation, which is a many to 1. So in conclusion, many to 1 function. Okay, do apologize for my writing. I'm trying to do my best here. Okay, now for part B. If you notice here, -4 is pointing to A and B, -1 is pointing to C, 7 is pointing to C. Wait, you notice something special here? That is 1 to many and many to 1. And then 3 is pointing to D, which is 1 to 1. So how do we describe this function? Very simple. It's a many, okay? Many to, many function. Okay, it's quite simple and quite direct. And part C here is actually very simple. It's a many to 1 function. Okay, as you can see, it is directly showing all the objects is pointing to one image. Okay, now let's go for the second part here. Okay, as we already clearly established, x is the object, y is the image. Whoever always take note, object will point at the image for a normal function. Okay, but let's identify the core components here. So they're asking in this question here is the domain, codomain, and range. So always remember, okay, domain means, okay, domain here means object, okay, and codomain here means image, okay, and finally range. Always remember, sorry, my spelling error here. Okay, range. So range is pointing towards any image that has an object. Okay, so yeah, okay, anyway, please apologize for my writing. I'm trying my level best again here because I'm not using a tablet, I'm just using a sketchpad. Okay, so again, range is any image, okay, that has an object. Okay, very simple. Okay, so let's have a look at part A. Let's try to do part A first. Okay, so again, domain. So I'll just put a simplified version here. Domain is P, Q, R, and S. How about the codomain? Okay, so the codomain here is very simple. Whatever image that you see, which is 1, 3, 4, 7, and 9. Now comes the interesting part. How about the range? Very simple. Whatever image that has an object, which is 1, 3, 7, and 9. Okay, as simple as that. So if you can see, the other B and C here is just two different types of ways other than the set notation here on how they represent a function graph. Okay, so if you notice here, part B is a graphical method. Okay, let's just always remember f(x) is just the y and x is your object, hence y is your image. And same goes for part C, where you can just trace. Okay, image that has an object which is 2 to 2. Let's just look at part C here. 2 is pointing to 1. It's as simple as that. Okay, now let's go for the more challenging one. So let me erase this. You can pause it to take notes. Okay. Okay, let's go. Okay, so now let's have a look at the last section here, the last question here, on how does this question is being solved. Okay, the function is given as f(x) is equals to modulus 2x minus 3. Okay, interesting. There's a modulus there. So how do we solve this question? Okay, let's take it step by step. Let's go for part A. How do we solve f is with the x value is equals to -2, meaning x equals to -2. Okay, so just take the function, which is 2, and now the x here is -2, right? So substitute it, like algebra, -3, okay? Just solve it, okay? So let's have a look, how do we solve this? Okay, so 2 times -2, you get -4, minus 3, which is equals to modulus -7. Remember, modulus makes everything positive. Hence, final answer is 7. Okay, so if you notice even this graph here, usually the graph of a normal function, okay, let's just show this, okay, normal function here, if the function f(x) is given as 2x minus 3, the graph will just go in a straight line. The y-axis is the y-intercept here will be -3, and then it will cut at the x-axis at 3/2. Because of the modulus, now the function actually reflects this whole negative region here towards the positive side. Hence, you'll get a function like this. So it will cut at 3 now. So that's the interesting part of the modulus. Okay, anyway, let's have a look on how does the modulus affect any calculation. Okay, so let's go. Now, if you notice, the function here, f(x) is equals to 5. Okay, meaning modulus 2x minus 3 is equals to 5. So now, what happens if you dump the modulus to the right hand side? What's going to happen? Let's have a look. So 2x minus 3 will become plus minus 5. Interesting, right? So the modulus from the other side will go from the left to go to the right and make whatever on the right become positive and negative. So it exists in 2 regions. So let's solve the first one, meaning 2x minus 3 equals to 5. And then the second equation here is 2x minus 3 equals to -5. So if you notice here, 2x is equals to 5 plus 3. We will get 8 divided by 2. And the x is equals to 4. Okay. How about this side? 2x equals to -5 plus 3 equals to -2. Interesting, right? Divided by 2, x equals to -1. So if you notice here, there's 2 values of x. Okay, so do take note. 2 values of x for the function given. So which one do we take? We usually display both answers, and because of the modulus, hence it exists in both regions. Okay, now the next concerning part, okay, is how does a function map onto itself works. Actually, it's quite simple too. Okay, map onto itself meaning, okay, the function f(x) is mapping onto itself. Means modulus 2x minus 3 is equals to x. Hence, how do we solve it? So 2x minus 3 is equals to plus minus x. Simple as that. So as you can see, let me do it a bit quicker now. So 2x minus 3 equals to x. Hence, if I rearrange it, 2x plus x equals to 3, 3x equals to 3, x equals to 1. Is the first answer. Second answer is 2x minus 3 equals to negative x. So 2x plus x equals to 3, 3x equals to 3, x equals to 1 as well. One moment, I think I've done something wrong. Oh, here we go. You see, this is a very, very careless mistake. This is supposed to be minus, isn't it? You see, this is where we learn from the mistake. So minus here, meaning we'll get only x equals to 3. There we go. You see, we always do mistakes. Please do check again. Okay. Anyway, now let's have a look on the last question. Okay, because part E, I think you can do it yourself because it's kind of similar with part D. Okay. Let's have a look on the last question for today. Okay, domain of fx. Okay, fx is less than 1. So they're asking you what's the image for this. Okay, very simple, they're asking you what is x. Now, the modulus 2x minus 3 is less than 1. So if you dump it on the other side, 2x minus 3 is less than plus minus 1. Interesting, right? So 2x is less than plus minus 1 plus 3. So we are looking at 2x is less than, if we 3 plus 1 is 4, or 2x is less than 3 minus 1 is 2. So it's either x is less than 2 or x is less than 1. Okay, so that's how the equation works. So now the biggest question here, how do you explain this answer? So very simple, you take which one covers the more range. So very simple as the equation is stating. Okay, you take the range which is covers the more area, which is x is less than 2, because less than 1 is below 2. So that means you just take this. Okay, so in conclusion, I hope you understand this first part. We will be discussing composite functions next week. So thank you so much for watching. Please subscribe, please hit the like button, and do support the video. Okay, thank you for watching. Bye bye.